Okay, we're back for part 3, lesson 8.10, AP Cal curriculum, volume with disk method revolving around other axes. This time we're going to do a video with a couple examples revolving around other vertical axes besides the x-axis or the y-axis. Mix it up every time I say it. Let's start first with let R be the region bound by the line y equals 1, f of x equals e to the x, and the line x equals 4. We're going to find the volume of solid created by revolving the region around the line x equals 4. As always, we'll start with graphing this so that we can see what it is we're doing. We have the curve y equals e to the x, y equals 1, and the line x equals 4. So this is the region R. We're going to revolve that about the line x equals 4. So, like we always do when we start this, when we're doing cross sections that are perpendicular to the y-axis, we're going to solve our curve for x, and we're going to invert and graph this with the y-axis in it. This is y. So we got y equals e to the x. We solve that for x. We get x equals ln y. So let's think about this. This is going to be when this is the y value. Y equals e to the 4th, where that intersection occurs. This is going to be at y equals 1. And this is going to be at the 0.14. Okay. So we'll draw a new graph where this is the y-axis now. This is the x-axis. We have the curve ln y. We have y equals 1. And we have the curve x equals 4. And we're revolving this about the line x equals 4. So our rectangle now is in here. And we're going to revolve here. I'm going to pull that one disk out. dy is my width now because I'm perpendicular to the y-axis. I need an expression for the radius. That's going to be 1 minus ln y. When I look at the distance here, let's go ahead and erase a little bit of that so you can see what's going on. The distance from the line x equals 1 to the curve ln y is 1 minus ln y. So I'm going to write an expression for the volume of one of those. It's going to be pi times the radius, 1 minus ln y squared, times the height, dy. Then I'm going to integrate that from the line y equals 1 until I get to, we said this was y equals e to the 4th. X equals 1, y equals e to the 4th. So we're going to integrate from 1 to e to the 4th, bring the pi outside, erase 1 minus ln y. That's all squared inside the integral dy. And that will give me my volume. Once again, I'm going to put this in the calculator that you can't see because my calculator on my computer is not working. So I'm going to enter pi, and then I'm going to do math 9 to get the integral up from 1 to e to the 4th. Then inside, because I'm squaring what's in there, I'm going to put an inside set of parentheses, open a parentheses, do 1 minus ln. And then again, because I'm working with a TI-84, I'm going to change that to x's. And I'm going to close parentheses again, raise to the second power, and integrate with respect to the variable. So in the calculator, what I put was pi times the integral from 1 to e to the 4th It automatically opened a set of parentheses. I opened a new one, put 1 minus ln. It opened another set of parentheses. I'll put x in here in the calculator, but I'm going to put y here just so it doesn't look confusing. I close the set of parentheses on the lny, close set of parentheses on the inside, the square, and then the calculator puts another set of parentheses for the integrand, and then I integrate with respect to the variable inside. That's the expression that's going to give me the volume. I'm going to tell the calculator to find that for me. And it says that volume is 841.917 or 8 if you round up, but I'm going to just chop because we can do that, and it's going to be units cubed. And that's one example. Now let's do another example. Let's let R be the region bound by the line x equals -2, f of x equals the square root of x, and the line y equals 9. We're going to find the volume of the solid created by revolving the region around the line x equals -2. Again, let's start by graphing. We have f of x equals the square root of x. This time, x equals -2. We're going to have to include the x-axis on there. So it includes the x-axis and the line y equals 9. I'll have to write in there that this problem's going to have to include the x-axis. So that this is the region we're looking at. And this is going to be where x equals . For y to equal, this is square root of x. So y equals 9 when x equals 81. Interesting. Assuming y equals 9, 0. So this is the region R in here. So like we always do, we're going to start by inverting this. I'm going to take and solve this for f of x, or solve for x. So I get y equals square root of x. That means x equals y squared. And since we're only dealing with one side of the y squared, when we flip this over the x and y axis, or over the line y equals x, that part's going to turn up to here. This is my y-axis now. This is my x-axis now. This is x equals y squared. This is the line y equals 9. And this is the line x equals -2. This is not to scale, by the way. So my region here is inside there. And I'm going to revolve that around the line x equals -2. So I'm going to draw one rectangle. The width is dy. Then we're going to have to figure out the height of that rectangle, because when I revolve this, I'm going to draw that. Oops, that's why. I need the radius. And the radius is the height of this rectangle, which is y squared minus -2, or y squared plus 2. So that's the radius of my disk. So the volume of one of those disks is going to be pi times radius squared, which is y squared plus 2 squared, and then times dy. To get the volume, I want to integrate now from 0 to y equals 9. Bring the pi outside because it's a constant multiple. And then y squared plus 2 squared times dy. And this is going to give me the volume of the solid generated by that. Now this one we can do by hand, so we're going to go ahead and do this by hand. This is going to be pi times the integral from 0 to 9, y to the 4th plus 4y squared plus 4 dy. And that's going to equal pi times, it's going to be y to the 5th. Oh, maybe we shouldn't have done this by hand. Or 5 plus 4/3 y cubed plus 4y, evaluated from 0 to 9. Only saving grace is that we don't have to evaluate 0 because it's all going to subtract out. All right, so it's going to be pi times, let's see here. Let's do 9 to the 5th. Oops. Divided by 5 plus 4/3 times 9 to the 3rd plus 36. Oops. Then we'll multiply all that times pi. Go ahead and get that in a fraction. Well, it's a big number. That's, oops, pi times 12,817.8 units cubed. Pi times that. Yeah, if we were going to do this on a non-calculator part, we would have just simply plugged in the 9. So that's pi times 9 to the 5th over 5 plus 4/3 times 9 to the 3rd plus 4 times 9 and units cubed. And we would have left it like that so that we wouldn't have to worry about on a non-calculator part on the AP exam. And that's a couple of examples of how we're going to use a disk method revolving around other vertical axes than the y-axis.